accident in the Soviet Union at Chernobyl's reactor 4, the scene of the total meltdown.
That explosion at a nuclear plant in the Soviet Union.
Nuclear reactor in Ukraine's Chernobyl power plant.
Of explosions powerful enough to blow up.
The Chernobyl disaster, a fusion of human error, technological failure, and the unforgiving power of nuclear energy, would leave an indelible mark on the world, reshaping perceptions of safety, technology, and the fragile balance between human ingenuity and nature's formidable forces. Join us as we explore the depths of what really happened in the Chernobyl disaster. The Chernobyl accident, which is often regarded as the biggest nuclear disaster ever, occurred on April 26, 1986, at the Chernobyl nuclear power plant in the Ukrainian Soviet Socialist Republic. At that time, it was part of the Soviet Union and is now located in Ukraine. There has been ongoing debate about the total death toll of the tragedy since 1986. Various sources, including the peer-reviewed medical publication The Lancet, have reported different numbers, leading to a lack of consensus. About 30 people lost their lives due to the immediate blast trauma and radiation sickness caused by the accident. Over the years, the number has increased to a total of 60, including those who developed a radiation-induced cancer. There's a lot of back and forth about how many deaths we can expect from the long-term health effects of the disaster. Some estimates say up to 4,000 deaths for the most affected individuals in Ukraine, Belarus, and Russia. Others suggest a total of 16,000 cases for everyone exposed in Europe, and some even go as far as 60,000 when considering the minor effects worldwide. Based on some research, it looks like the number of thyroid cancer cases caused by the accident might be around 1 in 10,000 by 2065. This is considered a worst-case scenario compared to other sources of cancer like diet and such across Europe. Thyroid cancer has been treated effectively for many years. Based on the estimated 16,000 cases in Europe by Cardis et al., it seems that Tuttle et al.'s 1% mortality rate could result in a final death toll of around 160 from radiation-induced thyroid cancer. There haven't been any confirmed increases in solid cancer among the liquidator groups. Liquidators were grown-ups when they were exposed, and most of them got doses of less than 100 MSV, which is actually lower than the usual levels of background radiation. What Chernobyl was. The Chernobyl nuclear power plant, situated near the town of Pripyat in Ukraine, serves as a chilling reminder of one of the most devastating nuclear accidents in history. Chernobyl was built in the 1970s as a key component of the Soviet Union's nuclear energy program. It was meant to demonstrate the country's technological capabilities and self-sufficiency in energy. The plant had 4 RBMK-1000 reactors, which could generate a significant amount of electricity using nuclear fission. The Chernobyl nuclear power plant in the Soviet Union was really important. It represented the Soviet Union's desire to use nuclear energy for peaceful reasons and to demonstrate its technological progress to the world. The plant has been a key player in Ukraine's industrial and economic growth, supplying electricity to countless households and businesses. But on April 26, 1986, everything changed. Reactor 4 exploded during a safety test, and it was a total disaster. It really showed us just how devastating nuclear accidents can be. The disaster unfolds. During the scram, the reactor output suddenly increased to approximately 30,000 MW thermal, which is 10 times its usual operational output. This information was displayed on the power meter on the control panel. It is believed that the power spike may have increased significantly beyond the expected level. The exact sequence of events that caused the reactor and power unit building to be destroyed cannot be determined. However, it seems that a steam explosion, similar to the explosion of a steam boiler due to excessive vapor pressure, was the next occurrence. It is widely believed that the explosion that destroyed the reactor casing was caused by steam pressure escaping from the damaged fuel channels into the reactor's cooling structure. This resulted in the upper plate, known as the upper biological shield, being torn off and blasted through the roof of the reactor building. It is thought to be the initial explosion that was heard by many. The explosion caused additional damage to the fuel channels and coolant lines, leading to the release of steam from the reactor core. The reactor's thermal power was further increased due to the combination of total water loss and a high positive void coefficient. Another explosion, more powerful than the first, occurred just a couple seconds later. This explosion scattered the damaged core and effectively stopped the nuclear chain reaction. The explosion further damaged the reactor containment vessel and expelled chunks of hot graphite moderator. The graphite that was expelled in the destroyed channels within the remains of the reactor vessel caught fire when they came into contact with the air. This fire played a major role in the dispersal of radioactive fallout and the contamination of surrounding areas. The explosion had a power equivalent to 225 tons of TNT. Observers outside Unit 4 reported witnessing burning lumps of material and sparks shooting into the air above the reactor. A fire was started when some of them fell onto the roof of the machine hall. Approximately 25% of the red-hot graphite blocks and overhead material from the fuel channels were expelled. Some components of the graphite blocks and fuel channels were located outside of the reactor building. Due to the building damage, the high temperature in the core created an airflow through it. The air caused the graphite to catch fire and ignited a blaze. Initially, there were multiple theories regarding the cause of the second explosion. Some experts believe that the second explosion occurred due to the combustion of hydrogen. This hydrogen could have been generated either by the overheated steam zirconium reaction, or by the reaction of red-hot graphite with steam, resulting in the production of hydrogen and carbon monoxide. Another hypothesis, proposed by Konstantin Chichirov in 1998, suggests that the second explosion occurred when the reactor lost all its water, leading to an uncontrolled release of fast neutrons and resulting in a thermal explosion. Radiation and its impact. The radiation release at the Chernobyl nuclear power plant on April 26, 1986, occurred due to a combination of factors, including a flawed reactor design, operational failures during a safety test, and inadequate safety protocols. The explosion of Reactor 4 resulted in a significant release of radioactive materials into the atmosphere. This damage affected the surrounding area and spread radiation across Europe and beyond. The release was made worse when the graphite moderator in the RBMK-1000 reactor caught fire, causing radioactive particles to spread even more. The health impacts of the Chernobyl disaster were significant and had wide-ranging consequences. Individuals who were exposed to high levels of radiation during the initial response experienced acute radiation sickness, resulting in symptoms like nausea, vomiting, and burns. Many people experience lasting health issues, such as a higher likelihood of developing cancer, specifically thyroid cancer, because of the release of radioactive iodine. Residents in close proximity, particularly those residing downwind of the plant, also suffered from health issues, such as increased occurrences of thyroid cancer, leukemia, and other illnesses associated with radiation exposure. Decades later, the effects of the Chernobyl disaster still have a lasting impact on public health. Research has indicated a higher occurrence of different types of cancers, such as thyroid cancer, in individuals who were exposed to radiation from Chernobyl. Furthermore, there is a worry regarding the possibility of genetic mutations and birth defects in children born to parents who were exposed to radiation. The impact of the disaster on the affected communities is also considerable as they continue to grapple with issues such as fear of radiation, stigma, and displacement. Continued efforts are being made to monitor and address the health effects of Chernobyl, which serves as a reminder of the long-lasting impact of this tragic event. Environmental consequences. The impact of the Chernobyl disaster on the environment, wildlife, and surrounding areas was significant, resulting in widespread contamination and ecological disturbances. Radioactive materials were released into the atmosphere, causing the spread of radioactive particles over a wide area. This contamination affected soil, water, and vegetation. The contamination has had long-lasting impacts on the ecosystem, rendering certain areas unsuitable for human and animal habitation. The Chernobyl disaster resulted in the establishment of the Chernobyl Exclusion Zone, an area around the nuclear power plant that is restricted due to dangerous levels of radiation. The Exclusion Zone encompasses a vast area of around 2,600 square kilometers, encompassing the deserted town of Pripyat, which used to be inhabited by workers and their families. This zone was created to prevent additional radiation exposure and to make cleanup and containment efforts easier. The Chernobyl Exclusion Zone has become a haven for wildlife, as the lack of human activity has allowed nature to take back the land. Many different types of wildlife, such as wolves, deer, boars, and birds, have managed to thrive in the area despite the presence of lingering radiation. Nevertheless, research has indicated that certain animals display indications of health issues linked to radiation, including genetic mutations and decreased reproductive success. The exclusion zone is a stark reminder of the long-lasting effects of nuclear disasters on people and the environment. Aftermath and recovery. The evacuation and relocation of affected populations following the Chernobyl disaster in 1986 were significant endeavors focused on protecting human health. Swift evacuation measures were implemented to protect the well-being of over 100,000 individuals living in highly affected areas, including Pripyat, by minimizing their exposure to hazardous levels of radiation. This evacuation was a necessary measure taken in response to the urgent danger of the nuclear accident. It ensured that people were relocated to safer areas and given the medical attention they needed. Efforts to contain and clean up the Chernobyl site were made with a focus on simplicity and clarity. At first, the damaged reactor was quickly sealed in a temporary structure called the sarcophagus to stop any more radioactive materials from escaping. The surrounding areas were cleaned up by removing and disposing of contaminated soil, vegetation, and debris. The completion of the new Safe Confinement, or NSC, in 2016 was a major step in containing the site and reducing environmental risks. Currently, Chernobyl is carefully monitored and managed with great attention to detail. The exclusion zone, covering an area of about 2,600 square kilometers around the power plant, is still off-limits to the public because of remaining radiation levels. There are ongoing monitoring programs in place to regularly assess radiation levels, environmental impact, and the health of wildlife within the exclusion zone. Monitoring efforts play a crucial role in comprehending the long-term impacts of the Chernobyl disaster and implementing essential measures to reduce risks and ensure safety. Even after many years have passed since the Chernobyl accident, its impact remains a constant reminder of the serious consequences that can arise from nuclear disasters. Continuing to monitor and manage Chernobyl is a clear reminder of the need to learn from past errors and prioritize safety and environmental protection in nuclear endeavors. The Chernobyl disaster serves as a clear reminder of the utmost significance of nuclear safety and preparedness. Chernobyl taught us a valuable lesson about the severe consequences of a nuclear accident on human health, the environment, and communities as a whole. The disaster emphasized the importance of having strong safety protocols, thorough personnel training, and efficient emergency response plans to minimize the impact of similar incidents. In addition, Chernobyl led to significant improvements in nuclear safety standards and regulations on a global scale. The lessons learned from the disaster led to a reevaluation and strengthening of safety measures, reactor designs, and emergency preparedness by governments, regulatory bodies, and industry stakeholders. The ongoing research, monitoring, and international cooperation in nuclear safety highlights the dedication to learning from past mistakes and enhancing the safety and resilience of nuclear facilities worldwide. The story of Chernobyl is not just a chapter in history, but a continuing saga of vigilance, innovation, and the enduring quest for a safer, more sustainable future for generations to come. That's all we have for you in today's video. Make sure to like and subscribe to this channel. See you in the next video.